What's up, guys? I am out at OSU today, so really when you watch this it's going to be January 10th, but today while I'm filming this is January 9th. So I'm going to upload these notes somewhere, but we are going to talk about angles today. So you should hopefully have your 10-1, 10-2, and 10-3 notes in the packets that are right here on the corner of the desk. Hopefully the sub passed those out to you guys. And we should probably in about a half hour, maybe a little less than that, get through both of these lessons. Actually, it might be way less than that. Chapter 10 is all about angle work. So the first section here, measuring angles, might be reminiscent of some work that you did in 6th grade. We are going to use a protractor to do all of this stuff. Now, we should have protractors sitting on the desk in the middle of the classroom, so if you need one, get one. Now, the thing about these protractors is they are the view-through protractors, so they actually can be flipped either direction, but only one direction is correct. So here's the deal. When you look at the protractor and you look at the very bottom, it says words. If you can't read the words, it's flipped the wrong way. At the bottom, it should say view through, because that's like the brand. That's what you want to make sure that it says. So get yourself one of those protractors if you need. And on the start side there, you saw that we had a protractor shown. So when we compare angle 1 to angle 2 and tell which is greater, we're going to need to measure both of them. So when we go to measure them, you're going to have to use your protractor correctly. Now, if no one's ever explained to you how to line up a protractor, what we're going to do is take the protractor, as you can see right here, line up the middle point, which on your view through just has a little, like, kind of looks like this, and it's got a little semicircle at the bottom. You want this point right here to line up on the vertex of your angle, and then you want one of your bottom lines, so either this bottom line or this bottom line, so over here, either this bottom line or this bottom line, you want that to line up with one of the rays of your angle. So if I were to measure angle 1, if you can see me on there, I make sure that I can read view through. I put my vertex at that angle, I put my one ray through my 0 line, and I look at where my other ray goes through. I'm not going to solve these two for you. We're going to talk about these when we come back together in class Wednesday. So make sure that you measure angle 1 and measure angle 2 and make a comparison about them. So, right here we have the definition of an angle. The vertex is where the two rays meet. So here, over here, the vertex of this angle is B. Point B would be the vertex. When we name an angle, we can name it two different ways. Over to the right here, I want you to write name. And we have two ways that we can do this. We can either show the angle symbol and just say angle B because the angle is at point B. Or we can use what we call 3-point notation for the angle, which is where I make my angle symbol. And then I would use the 3 points that make up the angle. But the really important thing there is this middle point has to be the vertex. So it's going to be the same as if I named it with a single notation, and it is the point that goes right in the middle of my protractor right there. So those are the two ways that we can name angles right now. And moving on. So we want to find the measures of angle 1 and angle 2. So take a moment. I'm going to pause my video too. Set up your protractor. Now, this is a little bit hard to see on your print. Angle 1 is the angle between the two skis. Angle 1 is this acute angle right in here. That angle right there. Angle 2 is the obtuse angle created between the ski and the skier. So right here is angle 2. So pause the video, measure these out on your own. So hopefully you tried this on your own. For angle 1, we would want to set our protractor with the vertex right here in that center point. One of my rays would be on my 0. And approximately when I find this measurement, and here's another way that we can write this. This is the measure of angle 1 equals approximately, it's 10 degrees. You might have got something a little bit over, a little bit under, because it's kind of difficult to measure these angles, but approximately it's 10 degrees. If we then go to do measure of angle 2, that's from here to here. Now, this is where some people struggle, and they say, okay, I found it to be 20 or 160. So approximately, you should have gotten about 160, And we should know that this isn't 20 because it's big. It's an obtuse angle. So hopefully you know the differences between acute angles and obtuse angles. Obtuse is bigger than 90 degrees. Acute is anything smaller than a right angle. But down here, we're going to discuss this more in the guide. So when we talk about how do we choose which set of numbers to use. So we have this protractor down here set up with angle CAB because A is my vertex. It's got to be in the middle. And I put my one line through the 0 point. Now, how do we decide which set of numbers we use? We are going to look for the 0. Wherever my ray has gone through a 0, so right here in this situation, that set of numbers is the set of numbers that we use for the entire thing. So now, if we're looking at this angle from here to here, I see where my line goes through. In the yellow set of numbers is right here between 100 and 110, and that's going to tell me. Now, if I don't want to write the M for measure, I do the little arc. That tells me the size of the angle, CAB, is 105 degrees. Now, the other thing that people will be confused and say, well, why isn't it 75? Well, we're not using that set of numbers because if so, this, if my line went from that line to this line, say I had an angle that was on top of itself, that's not 180. But if we use that set of numbers, that's what you would be telling yourself, is when a line is on top of itself, it creates a 180 degree angle. It doesn't. So, as we use this set that has the 0, that's the set that I use for the whole way through. Notice that over here, there's nothing through this 0 or nothing through that 180 because I'm starting over here at this 0. We're always starting at a 0. Now move on to the back. We want to draw examples of these different types of angles. So a straight angle is an angle where the two rays are straight with each other. So if my one ray starts heading out this direction, then to be a straight angle, my other ray would have to head out this direction. And this makes 180 degrees. A straight angle has a measure of 180 degrees. Now, an obtuse angle, like we just talked about, is any angle that is larger than a right angle. So if my first ray is here, if I went here, that would not be larger than a right angle, so that won't work. If I went here, that would be a right angle, so that won't work, because to be obtuse, it has to be bigger. So, if I go right here, that will be my obtuse angle. So this has to be more than 90 degrees, and it has to be less than 180. So that's why the straight angle is not called obtuse, because it is 180. Obtuse stops at 180. So once it turns into 180 degrees, it is a straight angle, not an obtuse angle. Now to be a right angle, I have options. I can either do this right angle, and that would be 90 degrees, which we show with that little box. Or I have the option to use this ray and come this direction, which would also be a right angle size of 90 degrees. So either way, I can do a right angle on the left-hand side and a right angle on the right-hand side. And my last one here is an acute angle. We're going to draw a cute little angle. So if I start using this ray like all the other ones, to be acute, it has to be less than 90. So my option would be there, which that's probably about 45 degrees if I were to guess. Or if I use this ray out this direction, I can use that ray with it, and this looks to be about 45 degrees. So acute must be less than 90 degrees. So if you want to label there, an acute angle must be less than 90 degrees. So moving on, we want to classify these angles. Pause this video and classify these as either right, straight, acute or obtuse. You may abbreviate if you would like. To start out here, I will give you one of these. When I see the right angle symbol, that box tells me that it is 90 degrees. That also indicates that it is a right angle. Right angles all have to be exactly 90 degrees. So pause the video, try these for a moment, and then come back for your answer. So hopefully you pause the video. Here I see that this angle is bigger than my right angle, so this would be an obtuse angle. I'm going to abbreviate and just leave it OB. This angle, if I think about what the right angle would look like, it'd be approximately right there. So we see that this ray is on the inside of where the right angle would be, and that makes this an acute angle. This angle, again, if I look at where the right angle would be, well, if I use that bottom line, the right angle would go straight up. So this is outside that line, which makes it obtuse. It is bigger than the 90. This one's really tough, but if you take another piece of paper and try to put the corner of the piece of paper in here, you'll see that the corner would actually give you a line out like that, and that's not a very good dotted line. But that is actually an acute angle here because it is slightly smaller than the right angle. And this, there's actually a vertex in the middle, so go ahead and draw that dot if you didn't yet. This is a straight angle. And hopefully you were able to figure out all of those, or at least figure out your mistake if there were any of those that you did not have. So now, let's classify right, acute, obtuse, or straight, but let's talk about which angles we can see here. So take a moment to think about what angles do we have. I want you to write the name of the angle. Use 3-point angle notation because we have multiple angles here that are sharing points. Since they're all sharing the same vertex point, I can't just say angle O because angle O could be talking about multiple different angles. I have to use the 3-point notation. So to use my 3-point notation, one way that I can do that, I do not need the measure, so I just need the angle symbol, is I can look at angle AOB. AOB would be this angle right here. What is that angle? What type of angle? Well, if I think about what the right angle would be, the right angle would be right there. This is on the inside of it. It is smaller than 90, so I see that this is acute. Try that on your own to identify any of the other angles that exist and what size they are. Pause the video. Come back when you have your answers. Another angle that I see is angle BOC. So if I use B to O to C, that's going to be this angle right here. Again, I can see where the 90 would be. This is bigger than that. So that equals obtuse, if I can spell that correctly today. And then the angle that most of you probably didn't think about. And if you did, high five to you or pound the fist. This angle right here, angle AOC. If I start and I use this ray out to A, this ray from O out to C, that is going to end up being a straight angle. So those are the 3 angles that we can make there. This is why we don't use O as the name of them, because all of them use O as their vertex. For our last problem on this paper, we get into how equation solving relates into my angle work. So we have this right here, and the first thing that I would do if I was you is highlight or notate somehow that this tells me that this is actually 90 degrees. That's what that little box in the corner tells me. And then it tells me the measure of angle 1 is 3x minus 15. Well, okay, that's fine and dandy, but I already know that the measure of angle 1 is 90. So it then wants me to find the value of x. So this is when it really turns into the equation solving, is I know this angle is equal to 90. I also know this angle is equal to 3x minus 15. So we set up 3x minus 15 is equal to 90, and then we solve this like any equation that we've had before. First thing I do is undo any addition subtraction. So I add the 15 to both of these. That's going to give me that 3x equals 105. I then, because the x is being multiplied by 3, I don't know why this keeps blinking. The x being multiplied by 3, we need to divide by 3. Now this gets a tiny bit tricky. If it was 100 divided by 3, I'd get 33.3 repeating forever. But 105 divided by 3, let's break this up. Let's actually make that 105, 90, and 15. So I'm trying to do this without a calculator. Obviously, you could use a calculator, but I'm trying to help you think through it without. If I did 90 divided by 3, that would give me 30. If I did 15 divided by 3, that would give me 5. So that tells me that this together is 35. So x would solve out to be 35. Try the got it on your own. Pause the video. Come back for your solution. So I'm going to zoom in a little bit here. Hopefully you have solved this problem on your own already. It shows me angle ABC, and then it tells me angle ABC is 60, but it also shows me that angle ABC is 2x minus 30. So I can set up my 2x minus 30 equal to 60. I start solving this using our equation solving techniques. We want to undo any addition or subtraction. So we want to add 30 to both sides. That gives me that 2x because my 30 is gone now, or my minus 30 is gone now, equals 90. When I then try to cancel out the multiplication by 2, I divide by 2.
Good afternoon. Leah Gimble, please come to the office. Leah Gimble to the office, please. Thank you.
And I get x is equal to 45. And, sorry, this does not actually need the degree symbol. I'm kind of glad I made that mistake. Because we have a degree symbol right here, we actually don't need a degree symbol on my variable value because that's just solving for what the variable's worth, not what the degree is. So x is part of the degrees. It itself is not the degree measure. That's it for 10.1. So go ahead and flip on over to 10.2 and we will continue that. This has taken me like 17 minutes, so I'm going to try to make the other one be a little bit shorter than this. We'll see how fast we can go. So flip to 10.2. I'm going to pause the video while I reset, and then I'm going to dive right into it. All right, guys, we are back in 10.2, and we are now talking about adjacent angles. So if I can remember that my software has changed. So the first thing we're going to talk about is what does it mean to be adjacent? So I want you to highlight adjacent or put a star, notate something next to it, and what it really means to be adjacent is next to, but not just next to. They're next to each other, they're touching, and they're sharing. So these two angles here, actually I'm going to capture them and get rid of that so we can see a bit easier. These two angles here, if we notate these, they would be BAD. I'm going to make that my blue angle. So BAD. Then, sorry that my line is not right on their array. I have CAD. So I'm going to make that my red angle. And what we can see is right here, we have a shared side. So they're touching on that side AD, and they also are sharing this vertex. So if I know that my two angles are sharing a side and sharing a vertex, that means that they are adjacent. And we will clarify that definition here, right down here. But what we get told is BAC, oh wait, we didn't talk about BAC yet. BAC measures 100 degrees. Well, BAC, that's the entire angle together. So that's the big angle that we didn't yet think about. They tell us that's 100 degrees. Identify at least 3 things we know about the measures of BAD and DAC without measuring them. Well, so without measuring them. If my green angle is the big angle that's made with my blue angle and my red angle, then what we could say mathematically is to get the green, I have to add the red and the blue. So we could say, I'm going to go ahead and keep this color-coded. angle BAD and if we're going to do and, that's addition, and angle DAC together combine to make angle BAC. So my blue angle plus my red angle combine together to make the big green angle. Now, another thing that I could say is if the green is 100, what must be true about the blue if the green is 100? So if I were to make a guess about the size of this, and I said, oh, it's 150 degrees, would that make sense if I guessed that this is 150 degrees? And then what would my red angle be so that when added together it would make 100? This wouldn't make any sense. Because in order for my red plus my blue to add together and make my 100 degrees, both of these have to be smaller than that. So the other thing that we know, sorry I keep forgetting that I can't erase like that anymore, is that angle BAD is less than 100, and angle DAC is also less than 100, because both of those angles are smaller than the green angle. So I can drag that to the right place. There we go. So both the blue angle and the red angle individually must be smaller than 100. So, again, our definition for adjacent. They must share a side. So I would like you to highlight, they must share a vertex and in a different color if possible, and a side. So we have our shared side right here, and we have our shared vertex right here. They both use vertex O. Here, we have a shared vertex. My blue angle and my red angle both share the vertex. But if I think about my blue angle using these rays and my red angle using these rays, do they share a side? No. So that makes them not adjacent angle because there's no shared side. You gotta have both to be adjacent. Now, almost every year somebody asks me, what happens if we share a side but one is inside the other? So let me give you an example like that. If I had angle ABC. So, sorry, that A looks pretty bad up there. ABC. So my vertex is B. These are both rays. And then I had angle ABD, but it's inside of here. So it uses ray AB. It shares the vertex B. So are these adjacent? The answer is no. Adjacent angles cannot be overlapping at all, where these are overlapping, or I like to say this is contained inside of the other. It doesn't count to be adjacent if the big angle, like the blue angle, has eaten the red angle. The red angle inside of it does not make it adjacent. If I'm adjacent to my sandwich, I'm next to my sandwich. Once I eat my sandwich, I'm no longer adjacent. When it's inside of me, it's not adjacent. So these angles would still have a relationship, but they don't have an adjacent relationship. So remember, adjacent angles cannot be overlapping at all. So I want you guys to take a moment, pause the video, and fill this in for angles adjacent to each of the reference angles. And notice here they want 2 angles adjacent, so you have multiple options. All you did was let the video play. Shame on you. Pause the video and try this on your own. Alright, so the first thing that I did was color code all of my angles. So angle FAD, I have it up here in yellow. We're only trying to find one angle adjacent to it, so we have to share the vertex. My vertex is A, so my second angle that is adjacent will have to have A as the vertex. It's got to be in the middle. It's got to share a side. Well, I can't share side F, because otherwise my one angle would be inside of the other, so I can share the side involving D. So if I use AD, well, I'm just going to say, okay, DA, and then where would the other side go? I could go DAB or DAC, and because I know you guys, you'll probably choose angle DAB, so go ahead and do a DAB if you want. That angle DAB would be adjacent because it shares vertex A and shares side AD. So if you had any struggles on that, pause again, try to figure out the adjacent angles to the green one on your own. But if I look at BGC, I need to share the vertex, so that's going to be vertex of G. And I need to share a side. I've got two sides available for sharing, BG and GC. So if I look at sharing this side, my first angle will have side CG, and then I can go wherever else I want. But if I come down right here, that blue angle is now adjacent to my green. So that would be CGH. So angle C has to come first. G is your vertex. CGH. And then if I go on the other side, I can use the BG, and then I could go up to F, or I could go over to D. I've got some choices there. So I'm just going to write that over here. We could do BGD or BGF if we wanted to. Either of these angles would be adjacent because it shares side BG and shares the vertex of G. I'm going to switch colors now to keep this a little bit straighter. CEH. So CEH, I've got that highlighted in blue right here. So my vertex is E, and I want to share one of the sides. If I share this side, I'm going to be sharing side CE, and then where can I go? Well, I can't go out here because that'll contain my angle. So if I go out this direction, they're just beside each other, and that would be angle CEB, because that point B out here. Or if I want to share this side, it's going to be HE, and then I can go up here to G, so that's also HEG to match question C. And then question D, I'm going to actually I'll capture it really quick, but then I'm going to erase all of this so we can look at this and make a little bit more sense. So when we look at angle ABC, right? So A, B, C. So we have a straight angle. Hopefully that's the first thing that pops into your head. Is this angle straight? Not acute, not obtuse. It measures 180. But when I go to actually look at it, I've got a choice. Which way does the angle open? Does it open this direction, or does it open this direction? Well, since we want an angle adjacent to it, and we don't want it to be inside of the angle, we're going to say that angle ABC is opening out here, so we can put an angle adjacent to it on the inside. So what we know it has to share is the vertex and one of the sides. If I make it share my vertex B and my side AB, I could do ABD, I could do ABG, I could do ABE, do ABH. I have a ton of choices here. One of the easiest ones is ABG. If I just do here, down to the B, over to the G, this will now be a right angle that is adjacent because it shares my side AB. Or if I use my vertex and my side with my C, then I'm going to have angle CB. Remember, your vertex has to go in the middle. CB, I could do E or H or G. So let's do CBE and bring that line right here. And then that green angle will also be adjacent because it shares a side, shares the vertex, and they are not inside of each other or overlapping. So, in the Got It, try this on your own. I'm actually just going to give you a few seconds while I drink some coffee. What is adjacent to EOD? If I was you, I would highlight EOD to get used to seeing those angles. O is your vertex. E and D are the ends of your rays. There are a bunch of choices here. Let's think about all the choices that use EO, because this is one of my sides that I would need to share with. So here's my vertex that I have to share. That goes out my ray. So I could do EO EOA would be one choice. I could do EOB would be another choice. Now here's a question. Can I do EOB since it's bigger than 180? So we talked about angles being under 90, at 90, between 90 and 180, or at 180. But what about over 180? Excuse me. EOB as an angle when we talk about it as EOB, excuse me, would actually not be that arc. It would be this arc angle, and that puts them overlapping. We can't use EOB. So if I'm using side EO, EOA is actually my only option, because once I go over 180, if I try to do this, that is not actually proper. That's not what we're allowed to do. So all of our angle measures, we always talk about being under 180. If I use DO, so D is the end of my ray, I can use DOC, or I could use DOB, because that is still under 180. And actually, if I go to try to use DOA, that's where it starts to fall apart, because my straight line would be right here, so that goes past my straight angle. So DOA would actually come this direction, so we can't use that, because again, they'd be overlapping. But I've got three choices: EOA, DOC, and DOB. All of those are adjacent to our start angle of EOD. So now we start to get deeper into using equations to help us solve these. So if I know that the sum of these two angles is 80, and I would like you to draw it like this, because if we draw this big arc, it helps our brain see the whole thing is 80, kind of like what we did on those balance scales. If I know that this is 80 and it involves 25 and x, well, I know the 25. If I get rid of the 25, what I have left is just the remaining angle right here. Well, 80 minus 25 is going to give me 55 degrees. So what we would say is the measure of angle QRS is equal to 55 degrees, and that is going to be our value of x. Now, in the did you know down here, this is kind of like a extension in a little bit, and we're just at 32 minutes, so give me at least 2 more minutes of your time. We're going to use this a lot, especially as you get into Math 8. So some of the relationships that we want to start to see is when we have adjacent pairs, they actually create more relationships than we think. Because if I think about angles that are adjacent to 2, well, I've got angle 1 is next to it and sharing, and angle 3 is next to it and sharing. Which actually means that in this image, how we see this, since these two angles share this line and this line, the size of angle 1 is going to be the same as the size of angle 3. We'll get to those relationships. Those are like a lesson or two further ahead from us. If we look at angles adjacent to 5, take a second and try to figure that out on your own. Angle 5 right here, we want to share one of the sides and the vertex. We could use 6, or we could use 8. And again, that actually, 6 and 8 are going to be the same measures with each other. We'll use that a lot as we get further up into this study. If ABD, the entire angle, is 40, and we know that this acute angle is 25, what would this acute angle be so that when they add up, they would give you 40? That answer would be 15 degrees. And that is the end of our notes for 10-2. We made it just in time, so you should have a few minutes to work on your homework. If you watch this at the regular speed, if you watched it fast, you probably have more than that. But please come to class tomorrow with questions over the homework that we can talk about, and then we will dive into 10-3 for tomorrow. Thank you guys very much. Have a great day. I'll see you tomorrow.